let's see longest increasing subsequence problem. So in this problem, it's saying we need to find out longest increasing subsequence. So this is not like sub-array. Sub-array should be contiguous, but in a subsequence, it should not be contiguous. So for this, like try to understand here, like from here, like we'll see which is the increasing number here. So from the 10, if you see all are smaller, but 101, that's the increasing subsequence. So we can take 10 and 101, so that's length is 2. So in this way we have to check for all the subsequences, and we need to find out which one is the longest one. So in this example, we have given starting from the 2. If you see a 2 and this 5 is greater, then 3 is lower, so we can ignore this 5, but we can take this 2 and the 3 is greater, that's increasing. And again 7, that's also increasing, and 101, that's also increasing, and then it's a decreasing. So this is the increasing subsequence: 2 and 3 and 7 and 101, and this 2. So this length is 4. So we need to return the longest increasing subsequence length. So that is the 4 here. So that's the problem we are going to solve. In this case, longest increasing subsequence count is just 1, because you can see 7, and okay, 7 itself is a subsequence, and it's a, if you see another number that's not in an increasing. So if it is 8, then you can say it's an increasing subsequence, but it's the same number, so in that case we can just say 1. So in order to solve this problem, we need to find the strategy. So this time I'm going to use a DP array again to solve this problem. And in a DP array, what we do, we create like, let's say example for this, it's a 1 2 3 4 5. So we create the DP array for the same size, and then we need to find out like what is the maximum increasing subsequence for this one. So that's just a 1. And if you come here till here, we need to find out what is the maximum increasing subsequence count. It's a 2 here, and here it's a 3, 1 to 5 increasing subsequence, and till here again it's a 3, because 5 is increasing and it's down, but you can say 1 and 2 increasing and 4 increasing, so 3. And if you come here, then it's a 4, so 1 2 1 2 4 6, so the count is 4 here. So every in a DP array, when we move to the when we iterate in a DP array, in each level we put the value, and that is the count of max increasing subsequence for the smaller number, and then grow to the bigger, bigger, and any index in a DP array we can say that is the maximum increasing subsequence. So let's move this example to another screen, and then we'll see this example, and then we'll write and comment code. So same example I put here, 1 2 5 4 6, and for the same length I will create the DP array, and in a DP array I just fill this DP array with 1. So every value is 1 here, and then I run one for loop starting from this 2. Starting from this 2, I run a for loop, and inside this another for loop I will run, and I will take this item and I will compare with this 2, 1 and 2. So if it is 2 is increasing order, if it is in increasing order, then that means I will update this DP array here. If it is increasing order, then I will also find the current max. So the current max is in this time till here I am here. So in a current max, I will see dpj. So dpj is like I'll start from here. So this is the 1, and then I'll come and update. I'll see the previous one is 1, and I'll add one more here, 2. So that means if you observe this dp array, so num we are 2, and in this index in a dp array also, this is maximum increasing subsequence is 2. So when we, in the same way, when the I pointer moves here, then again the j pointers, we start from this and this. So we'll run the j pointer 1 before this I pointer. So we come here and we'll see, okay, for the 1 is less than 5, or we can say the 5 is greater than this 1. Okay, that's good. In that case, our current max will start from the 0, but in this case it's less, so we'll increase the current max, and the current max is 1. So how will it check? In the current max, we'll check the current max is 0 and the dp array value. So dp array value is 1 in this time, so that's a 1. When you come to this plus 2, we'll check which one is the max, dp array of this or current max. So current max is 1, and the dp array value, this is a 2. So 2 is max. So we put the 2, and then 2 plus 1, we can put that in a dp array here, 3. So in this sequence again, in this index, if you observe till here, the max subsequence count is 3, because 1 2 3, that's increasing order. But if you come here again, we'll run the inner loop from 0, and we are here. So in this case, we'll check for 1 again. Current max is 0, then, and this is 1 is less than 4. Then we can check, and we'll check which one is the max, this one or current max. So current max is 0, so put the this 1 in a current max 1. Again we'll come to this place. 2 is again less than 4. Okay, as long as less than 4, we'll move on, and then again we'll come and see current max is 1, but dp here in this place 2. So current max, we make the 2. We'll come here, and the 5 is not less than, will not go in the if logic, and we'll stop here. So we'll stop here, and then current max was 2, and the 2 plus 1, 3. So in here also we update the 3, and again if you observe here, till here current max increasing subsequence is 3, which is 1 2 and the 4 3. And if you come here, the j starts from this place, and when it comes here, it was 3 and the plus 1 add 4. So that's the logic we are going to add here. So let's see the code now. So for now, I can say result is 1, let's say, and I can create the dp array, and this is make the int, and it's the length of nums. That's the dp array, and let's initialize this dp array with 1. So for I is equal to 0 and I less than length of nums I plus plus, and you can say dpi is equal to 1. So I initialize this, and this is our result. Let me create one function, max a b int, and if a greater than b, return a, otherwise return b. So we'll come here and we'll run a loop for I will start from 1. So I will start from this 2 here, 1, and then I less than length of nums I plus plus, and then inner loop j I will start with from 0. So every time we'll start from the 0 until I, like before I. So I can say the j less than I and j plus plus, and I'll check and then here we need one current max. So current max is, you can say 0 now, and then we'll check if a I, or not, this is it's a nums, so nums I greater than, so if I is here, then we'll check the I greater than this j. If the I is here, then we can check greater than j, and when j moves greater than j here till here, so we'll check that condition. If nums I greater than nums j, so in that case we'll update current max. So we'll say the current max is max of current max and then dpj. So we'll check the whatever the current max, like let's say our I is here and the j start from here, the j start and current max is 0, and then we'll check which is the greater, current max 0 or dpi. So dp0 has a 1 value, so 1 is greater, so, and then we update. So we are checking the value of dp array, not this nums. So on that index, what is the value of dp array? So current max we got here, and then come outside, and again we can update dpi is equal to current max plus 1, and then we need to maintain the result. So result is equal to max of result and dpi. So that's the logic. We'll run it, and then I'll print dp array, and again we'll understand. So let me run first. Okay, we need to return result accepted, submit. Okay, it's let me print this dp array before returning the result. It's a dp array is a dp. So when I run this, then we'll see this is the dp array 1 2 3 3 4, and exactly I explain the same thing here. 1 2 no, that's the different example. Nums 1 2 5, yeah, that's the same one. 1 2 3 3 4, so that's a dp array. Yeah, so go through the code and just understand the logic I explained in the beginning, and that's exactly match over there. So that's all for now. Thank you.